Okay, so hello everyone. My name is Clemens Zagler. I'm part of the Open Data Hub maintainer team. I'm a software architect here on the Netex Park in the tech transfer digital unit. So today I will tell you something about how we implemented Netex in Siri in the context of the Open Data Hub. I think some of the context you got already by Roberto, and there's also some details regarding converters and such that you already heard about. So we will return to the protocols itself. I will explain a bit more in detail what these protocols implement. As you saw before, there is these two parts to the transmodel class of standards, I would call them. So there is Netex, which is used for static data. So the abbreviation is Network Timetable Exchange. So this is like what are the stops, like timetables for buses, trains, and so on, like very static data that doesn't change in real time. And then Siri is used for the real-time updates. For example, if a train is delayed or a GPS position of a bus or something along those lines. Both of these are defined as XML standards. But for Siri, we will see there is I wouldn't call it standard, but there is like a living ad hoc standard of providing it also in JSON format in a restricted subset, which is called Siri Lite, which is the one that we've implemented. Okay, so these are the parts of Netex defined by the European Committee of Standardization. So the part one is public transport networking topology. So these are just, again, bus stops and so on. And you have timetable schedules. In bold, I put what we actually interface with, so what we provide on the Open Data Hub. You then have fare information, which we don't have any data about. I think except for car sharing, now we maybe have some, but we don't export it yet. And then there are also part 5, the alternative modes, which is the new mobility as a service things like car sharing, bike sharing, like alternative modes of transportation. And then, as you already heard, there is this proclivity of using profiles of the standard. So each country, or more or less each use case, uses its own small subset version of the standard, which makes it a bit more difficult. There is an Italian profile used in the context of this Mass for Italy project. And you can find the definition. There is examples, there is XSD files, there is also documentation at this GitHub repository. And the Italian profile defines multiple levels. So these are not parts, this is a different thing. What's important here is, again, important for us, the level 1 is the one providing the static transport relevant data. And level 4 are these alternative mobility modes. Siri is the real-time part of the transmodel protocols. I'm not going through all these. So this is the exhaustive list of services that are defined within the Siri standard. But as you see, this is a lot of stuff. And in actuality, the countries, again, have their own profiles, which are very much reduced. So for example, the Italian profile is only restricted to those 4 services. Especially important for us, the only one we implemented the Open Data Hub is the facility monitoring one, facility monitoring, which is real-time updates on, for example, parking stations and also sharing services. Then, as I said, there is this somewhat standard, but I actually haven't found any real documentation about how to implement it. It's more or less Siri can also be translated into a JSON format for a REST API. So because Siri foresees multiple, it's actually a protocol, so it foresees multiple types of communication. The classical, you make a request until you get some data, but there is also a subscription model. So you can say, I want these kinds of updates, and then you can push the update. So it's rather complicated to implement, and on top of that, it's all XML. So there is this simplified Siri version called Siri Lite, which is just classical REST, HTTP, how you know it, and then you get a JSON, which is a direct mapping of the XML structure. But as I wrote here, Siri Lite is not, I found some PDF from some French agency that implemented it once, just took the data structures from XML and translated it. I don't know how far the standard is along. Maybe now we have some actual documentation on this, but when I implemented it about a year ago, I didn't find anything at least. but it seems to work how it is. Okay, so to get back to the role that the Open Data Hub plays in this project, you've seen there is the national access point, so there's an Italy-wide access point for that all the mobility as a service operators can use to get the data. Then each region, or in this case province, has its own regional access point, and we are providing part of the data of the regional access point of the province of Bolzano. So all the timetable scheduling data is provided by STA, the transport authority, and we on the Open Data Hub, since we have mobility, we have those alternative mobility mode data, for example, car sharing, bike sharing, and also about parking stations, and we only provide that data to the regional access point. So what did we need to implement to provide this part of the regional access point? We do an on-the-fly translation from the Open Data Hub, so we implemented an API that when it gets requested from the national, the regional access point, does the request to the Open Data Hub API, on the fly translates it to the Netex or Siri format, and then returns it. We did all this, obviously it's open source, like all of our projects are. All the data that you can request on that API is CC0 open data, so you can use it for whatever you want. And also we decided to make this API public and accessible to everyone, so not only is it part of the regional access point, you can also directly access this API if you want to interact with the Netex or Siri services. And this is how it works in practice. So we have the transmodel API, and depending on the request you do, so there's the Siri-Lite part, the Netex part, we do a direct request, and one of these data sets, or all these data sets, are aggregated here. So we have parking, e-charging, bike sharing, bike parking, car sharing. I think I put bike sharing twice, so it's more stuff. But yeah, actually, what the part that's interesting is we are misusing the e-charging data for parking, because e-charging stations are, in effect, parking stations as well. So we are providing these to the national access point as parking stations. And since we have real-time data about the occupancy of the e-charging stations, we can say, okay, this is a free parking space, or it's not. Obviously, you should only park there if you have an EV, but I hope they put that disclaimer somewhere. And then we have a special edition as well. So we also have flight data. So we have in GTFS format, or in general, we have the flight data from SkyAlps, so from the airport of Bolzano. There is some criticality about changing APIs and so on. So right now the data is not exactly there, but it used to work and it will work again. So we have the flight data of SkyAlps. And we also provide this. So this is the only static transport relevant data that we provide. And here we don't have it, or we don't get it from the from the API of the Open Data Hub, but instead we have a GTFS API here that is also public, that you can also use, where you can retrieve the GTFS of all the SkyAlps flights. And then we use a GTFS to Netex converter, so it's interesting to hear about the converter you guys are working on. This one has been developed by the guys from the region of Liguria, which unfortunately are not here and would have had this slot. It's an offline CLI tool written in Python, so we provided our own API wrapper, so we can use it like an API. I will link the repository afterwards. But suffice it to say, this is, I think, very interesting that we are mapping this GTFS to Netex and exporting it on our API, because for future use cases, it should be fairly easy to add other sources as well. So if someone has GTFS data, maybe some other mobility providers, other airports and stuff, so we can add it fairly easily. This is the Swagger. So the API layout is fairly trivial. It's just you have a Netex route where you get all the Netex data together, and then you can also only get the parking data, only get the sharing data, or only the flights. And similar stuff for Siri-Lite. Right now we only have the facility monitoring, and then we have parking and sharing real-time data. If you go to the Swagger, there are some links to the Siri APIs of STA. So if you want to check out the other Siri services from the national profile, you can find the links there, but they are not hosted by us or not implemented in this API. This is how it looks. So if you make a request, it's you see did a curl request here. This is just the Netex parking data. It's just a huge XML file. So this is what Netex looks like in the flash. Same stuff for Siri-Lite. So our API actually can do both. You pass you just pass an HTTP header, and then you can say if you want an XML or if you want a JSON, and it respects it and gives you the XML, or in this case, the JSON. So you see it's just one-to-one mapping of the structure. What did we use to develop this? So the whole API is written in Go. Uses Gonic, I don't know how to pronounce it. So it's like a Express type framework, like a web application REST framework for Go. I think it's almost the most popular one together with Echo. We used the GTFS to Netex converter. So if you are interested in that converter by the region of Liguria, you can check it out here. We also did that API that I talked about. So this GTFS to Netex API thing is just a very small Dockerized API wrapper around the tool. So if you want to use the tool, but not as an offline batch style translator, then you can use our API wrapper for it. We used XML-lint, which is like a very well-known Java library to do XML validation. And what's important, we started our own Netex Golang XML bindings, because there are none. I haven't found any libraries that provide Netex data structures, so we started it. We currently cover our own use cases only, but we are very much looking for contributors, and we are also interested in bringing this into a more complete implementation. I think I will get back to it afterwards. So having implemented this, these are some of the challenges that we faced. So the first thing is Netex has all the complexity of a standard without the homogeneity. So the problem is you have a huge standard, but then everyone defines their own profiles. So it is quite difficult to use tools, documentation, and so on of others who have already done the work, because they're actually using a different subset or a different variation of the standard. So this has been a bit challenging. So we pretty much have to rely completely on the Italian stuff that is in development. And during the implementation, I know now it's gotten a bit better, the standard and documentation were actively in development during our implementation. So every time you pulled from the Git repo, there was some change, and sometimes there was some updates, or you had developed on outdated information. Then the Java developers will be very happy, because afterwards I will do a talk where there will be some Java bashing, but now we'll praise Java because the XML support in Golang is pretty, I wouldn't say bad, but it's pretty basic. So since there's a lot of XML wrangling here, I'd say that maybe Go was not the right choice, I'm not sure. I just say there is some pre-existing library stuff for Java if you want to look into implementing these protocols. The support for Golang is pretty basic. As I said, we started our own library because we couldn't find anything. Then we had the problem that Siri was not really well defined. Also, the Netex standard is just huge. So it's pages and pages of XML. I think like the documentation of the Italian profile, I think it's around 180 pages right now. And that's only the Italian profile, which is a small subset. So, and then obviously you have to read the actual standard and then the Italian standard. So it is difficult to handle. It's not something you just write down. Also, we ran into some difficulties in, so there was conflicting documentation. So sometimes the documentation did not match some implementations. Sometimes the validation was quite picky. So it could be that I changed some stuff, ran the validation, it said, oh, it's good. And then the next guy's validation said, oh, no, it's not good, or vice versa. So we had some of this as well. So you couldn't rely on the XML validation. So yeah, and at the end, I want to call you again. If you are in some way interested in using Golang together with Netex, you can contact us. We've started this library. It's pretty basic right now, but we are very happy to help bringing it to a more complete coverage of the standard. It's completely handcrafted. It's just from data structures for the Go standard library to map Netex to objects. And it's licensed under the MPL license, so it's quite permissive, so you can even use it in commercial projects as well. Yeah, so these are the links, and since I only have 20 seconds left, I would say I'll leave it here. Thank you for your attention.